Alright, good day, my name is Mark, and this is a continuation of the comprehensive tutorial about emulator 8086, and we will be using the program Emu8086 assembler and microprocessor emulator 4.08, and we'll be producing the module 2, the conditional jump instruction. On the previous module, we are able to discuss the jump instruction, simply a simple jump instruction without any condition. But right now, we need to satisfy any of the following condition in order for us to perform a jump instruction. So we will be studying each and every of the jump instruction comprehensively. So jump if 0, if the value of the previous process is equal to 0, then we will be performing a jump action. Jump if not 0 simply pertaining to perform a jump if the answer to the last process is not equal to 0. And for the next module, we will be discussing these conditions using a compare. We will be comparing two values using the following jump conditions. Jump if equal, or if the two values on the compare is equal to each other, then we'll perform a jump. And another thing is JNE, it's jump if not equal. We'll be performing a jump if the value is not equal to each other, and then jump if above if one of the statement or one of the register has a value above another register, then it will perform a jump. Another thing is jump above equal, that is if the value is greater than or equal to a certain register or an immediate value, we will perform a jump. Jump if below, commonly known as less than, we will perform a jump if the value of one register is less than the value of another register or an immediate value. Jump if below or equal, it will perform a jump action if it is below or equal. So let's focus on jump 0 and jump not 0 for this module. So let's proceed with emulator 8086. So as you can see here, we have some set of the initial or the starting code, which is an include an origin of 100H, and a return statement, which is the last code that will give our program an information to terminate the execution. So again, let's do the jump. So let's have an AX or move to AX, a value of 5H, and let's perform move CX to DX, a value of 4H or 1, just 1, a decimal 1, and then let's perform a decrement. Decrement means it will be decreased by one step. So 1 in decrement of 1 is 0. 2 a decrement of 1 is a 1. A 3 decrement of 1 is a 2. And a 50 decrement of 1 is 49. Will be decrement dx, producing a 0 answer. Then let's use the JZ, or jump if 0. And jump, this is our jumping instruction. And the landing instruction, of course, the name of the anchor, the colon, this is the landing instruction. Alright, so how the jump 0 and jump not 0 works? It will analyze the last answer from the last command being performed. So the last command before the JZ is the decrement of dx. If the decrement of dx produces an answer of 0, it will jump. If the decrement of dx produces an output of not equal to 0, it will not perform the jump instruction. It will just simply ignore it. So let's try to execute this. So just follow the yellow line. So this is the next code to be executed. Let's do the single step. It will be moving 1 to the x. You can see this. This is the dx having a value of 1. And then a decrement. So producing 0. So the answer to the process or the command before the JZ is equal to 0. Therefore, we are able to satisfy its condition. The condition is jump if the answer to the last command or the last process is equal to 0. So we will perform a jump. We jump here, proceed to return, and that's the end of the code. Therefore, we are able to skip this one. Remember, the jumping instruction is above the landing instruction. Therefore, this is an skip statement. We are able to skip this set of code because we are not able to satisfy the condition. So let's make this the dx equal to 2. So let's analyze this. Dx being 2, decrement of 1, 2 decrement of 1 is equal to 1. So the answer to the last process before JZ is equal to 1. So is 1 equal to 0? The answer is no. Therefore, it will just ignore this and not perform a jump instruction. Proceed with line 8. Line 9, we will be moving 5h to ax. Jump. Move here to the line 10. And the landing instruction, just ignore. This is just a simple information, not a command. Line 12, 13, return, and that's the end of the code. Let's try to run this. So move 2 to dx. We have 2 to dx. Decrement it by 1. We have 1. So the answer to the last command is 1. So is 1 equal to 0? Of course not. Then it will just ignore the jump instruction. Proceed with 5, moving 5h to ax. Then there you go. We have 5h on ax. And just ignore again the land instruction since it is a simple information where to land. And end. That's the end of the program. Alright, so let us make a JNZ combination. So we will be satisfying this one. We need to achieve this. Store 5h to ax if the if equal to 0, and store 1h to ax if the value of our last process before the comparison is not equal to 0. Okay, over this so that we can see it. Alright, we will be storing 5h to ax if the answer to the last process is equal to 0, and store 1h to ax if not equal to 0. Right, so the thing here is that we need to make two conditions. If the answer to this one is equal to 0, we will be storing 5h to ax. So that means that if this thing is equal to 0, it will jump from here to here. Therefore, we can place the code here. Right? Ax 5h. However, if the ax is not equal to 0, if the last process is not equal to 0, the ax should have 1h. So we can make this 1h. Since if the value is not equal to 0, we'll just proceed over here. Right? But we will encounter an error, so let's just satisfy this first. So if again, if the last process equal to 0, we will be storing 5h to ax. So let's move in. We have the value of, alright, let's make this 1 first. The dx is equal to 1. If the value, let's move 1 to dx, single step. Alright, so we have 1 on dx decremented by 1, of course, equal to 0. So if the value of the last price is equal to 0, we will be jumping to a. So from jumping instruction to the landing instruction, it will jump and proceed to the next set of code, which is move ax 5h. Alright, so we'll be storing 5h to ax. There we go. We have 5h on ax, so we are able to satisfy that if the answer to the last price is equal to 0, we have 5h to ax. However, if you make this 2, the flow goes like this. We will be moving 2 to dx, decremented by 1. The answer is 1 and not 0. So jump f0, since it is not 0, it is 1. We will proceed by ignoring the jumping instruction, and we will be moving 1h to ax. Alright, so we have 1 to ax. But since we are just ignoring this one, the landing instruction, and will still proceed over here, we will overwrite the value of ax with 5h, producing a wrong answer over here. So we have still 5h on ax. So in order to compensate that, we just simply add a jump instruction over here. We can jump and call it skip, or JMP, skip, and we can place this skip right here. Let me get that. So if the value is not equal to 0, it will proceed here, store 1h on ax, and will proceed to line 10. We'll encounter a jump to skip. It will skip this code, which produces our error. So it will jump from here to here, and then proceed with 18, 19, 20, 21, and the return instruction to end the program. Right, so let's make this one a clear one. Okay, so this is the jump instruction. Let's see how it works. Oh, there's an error. Where is the error? JMP. So name this. So let's just name this as B. Alright. I get it. Skip the colon sign. Alright. So we will be storing 2 to the x, decremented by 1, producing 1, and that is not equal to 0. So we'll be moving here the jump instruction. We'll just ignore that since it's not equal to 0. We will be moving 1h to ax, encounter a jump over here from the jump instruction to the landing instruction, the skip, and produce the return. Therefore, we're able to store 1h on ax. Right, we're able to store 1h to ax since it's not equal to 0, so we are able to satisfy this. It's correct. Let's try this again, producing a 0 answer. So let's make this 1, emulate it again, single step. We'll be adding 1 to dx, decremented by 1, producing 0. Encounter a jump instruction. Since the answer to the last process is equal to 0, it will be performing a jump. It will jump, storing 5h to ax. Just ignore the skip since it's just an instruction where to land, and the returns. Alright, so we are able to store 5ax, 5 on ax, so we are able to satisfy this condition. So this is how the jump instruction works. The jump if 0 and jump if not equal to 0. We will be proceeding to the module 3, which is just a conditional jump instruction again, which tackles compare, jump if equal, jump not equal, jump above or jump above equal, jump below or jump below equal, in a short while. So if you have questions, please do comment below.